two kinds or three kinds of t-tests, but majorly we group them into two: the independent t-test and the paired t-tests. But before you are able or you are allowed to use these two tests, there are assumptions or conditions that you must meet before you are allowed to use the t-tests, or else your results will not be valid, and you'll be violating the rules that have been set for the use of these tests. And as I said the other day, this is a parametric test that usually tests the statistical significance. So if you are going to use this t-test, then you must meet the following three conditions. The first condition is the test of normality. The test of normality. The data you are dealing with should be normally distributed within each group. This means that the data should follow a bell-shaped shape. The curve, which I did show you in our first course, the normal curve, and most of the data points are clustered in the middle and spread towards the flanks. So the mean is at the middle and the fewer data points are extremes. So if the data is not following the bell shape or the normal curve shape, then this test cannot be used. It will have violated this condition or this assumption. So in order for you to use t-tests, you must be able to use to meet the normality test. The second is independence. The second assumption is the assumption of independence of the data. The observations within each group should be independent of each other. This means that the values of one observation should not be influenced by the values of the other observation. Your data should be independent, or your observation should be independent. If the values are influencing each other, like the observation you are going to record is influenced by another observation in the same group, then this assumption is violated, and then you cannot use this assumption. Number three is the assumption of homogeneity or variance. Homogeneity or variance. The variance of the group being compared should be equal or approximately equal. How do we get the variance of various groups? We do calculate the mean and the standard deviation of these groups. When we look at the standard deviation of these groups, the standard deviation should not differ so much between the groups. Whether you are dealing with a paired t-test or independent t-test, because in both we are using some group data. The homogeneity of variance means that you've calculated the standard deviation of one group, and when you look at the data of that group and the data of the second group, the standard deviation does not differ so much. That's what we are calling the homogeneity of variance. But if it differs so much, then you'll have violated this assumption. Then you should be able to use the non-parametric test of the equivalence. Now, this means that the spread of the data should be roughly the same in both groups. They should not differ so much. Now, if these assumptions are not met, The results of the t-test may not be valid, and the conclusion may be inaccurate. Therefore, it is important to check that these assumptions are made before conducting a t-test and use the appropriate methods to address violation of this assumption, such as using the non-parametric tests or transforming the data to confirm before you use it for these tests. Whenever you will be using this test and you will be presenting your data, your findings, many people will be concerned. They will be asking you, did your data made the assumptions, and this will be the assumption of normality, the assumption of independence, and the assumption of homogeneity or variance. So when the data has met all these conditions, then you are in a position to use it, to use the t-test. But if not, use the equivalent non-parametric test or transform the data before you move. Now, I want us to look at examples of t-tests in educations or in education setup where we can use independent t-tests and the accompanying hypothesis we have to come up with, because these t-tests usually tests give us a measure on which we test so that we can be able to reject the null hypothesis or fail to reject the null hypothesis. In education, independent t-tests can be used to compare the performance of two groups of students on a particular measure, such as standardized test score or grade point averages. And here are a few examples. One, when we are doing the comparison of the performance of male and female students on a math test. So what does this one entail? A researcher will want to investigate whether there is a significant difference between the mean score of male and female students on a math test. They will go out to collect the data from the independent groups of students. One group will consist of the male students and another group will consist of the female students. Then they use an independent sample t-test to compare the mean score of both groups. In other words, you will calculate the t-test from one group and the other one, and you compare both mean to see whether these two mean are different from each other. Now, what will our hypothesis, the null hypothesis, look like? This is how we will state our null hypothesis, that there is no significant difference between the mean score of male and female students on the math test. Because now we have started stating our null hypothesis, and it's very important that now we get it right as we are able to move on now. I'm looking for a in color so that I'll be able to shade my null hypothesis. So this one will be our null hypothesis. The one I've said, that there is no significant difference. The word is difference. There is no significant difference between the mean scores of the male and female students on the math test. Now, this kind of The null hypothesis, it's called a two-tailed because it does not give any direction. It does not favor male or female students. It only states that there is no difference in the mean score of the male and female students. So it's called a two-tailed or a non-directional null hypothesis. This means that when we calculate the mean of male students in the scope of mathematics, and we calculate the mean of the female students, these two tests, these two mean should be equal. That's what we mean, or that's what we are implying in our null hypothesis. Then there's an alternative hypothesis. I will give, before I go to the null hypothesis, there's another hypothesis we can state in this manner, that the mean score for male is different from the mean score of female on the math test. The mean score of male is higher than the female mean score on the math test. Remember, the first null hypothesis was there is no significant difference between the mean score of male and female students on the math test. This one is a non-directional hypothesis. It does not give the direction of where we're going. But when we state the hypothesis that the mean score for male is higher than the mean score for female students on the math test. So we have taken a direction. We have already said that the mean score for male is higher. And we have said that of female is lower. That is the direction we have taken. So that kind of an hypothesis is said to be directional hypothesis. And also, it's also said to be one-tailed hypothesis. The alternative, in the absence of a null hypothesis, we usually have a null hypothesis. And the null hypothesis in this case will be, or will state, there is a significant difference between the mean score of male and female students on the math test. That will be now the null hypothesis, that there will be a significant difference between the mean score of male and female students on the math test. That will be an alternative hypothesis. Now here, we have example number 2. In the education settings, we might compare the effectiveness of 2 teaching methods. A teacher may want to determine whether a new teaching method is more effective than the traditional teaching method for teaching a particular concept. And he will randomly assign 2 groups of students to each method and administer a test to measure their understanding of the concept. The teacher then will use an independent sample t-test to compare the mean test scores of the two groups. So this is also another scenario where we can use a t-test. We have a teacher has a new teaching method, and you will want to know if this new teaching method is more effective than the traditional teaching method. Then if he has to proceed and he wants to use this sample t-test, independent sample t-test, he will then assign two groups of students to each method of administration, and he will administer a test to measure their understanding of the concept. Then the teacher will use a independent sample t-test to test for this. But I want us as a class now to look at this and come up with a null hypothesis, non-directional. Null hypothesis that is non-directional. Because if we don't try sometimes these things, we might get that so difficult and we are not able to. So I want us to get some non-directional null hypothesis. Let us start with Paul Hector. On this example that I've given, can we come up with a null non-directional hypothesis?
Yeah, okay, Doc. Maybe you can say that the null hypothesis is that there is no significance between the two teaching methods, the traditional teaching method and another new one towards that subject, or when you are comparing the two.
There's something you forgot in your sentence.
Yes.
It should be there's no significant difference.
Yes.
Between methods.
Yes. There is no significant difference. The word significance is very important because the test statistics you are going to use, it measures the significant difference, statistics significant difference. But if you just say difference, then there might be a difference. But we are looking for that statistical significant difference, which we are going to use this statistical method to measure. Thank you. So this one, I have it here, that there is no significance different between the mean test score of two groups of students taught with the two different teaching methods. Can we give a directional hypothesis, Gladys? A directional hypothesis.
The mean test scores for the new teaching method is more effective than the traditional teaching method.
More effective? How do you know it's more effective? Can you use the word higher?
Yeah, it's higher.
Yes. So you have with that directional hypothesis, you are now giving one preference over the other. Or you can say the mean score for the old method is lower than the new method. You are giving a preference for that. So that one becomes a one tail or a directional hypothesis. So we have also the alternative hypothesis for this. So the alternative hypothesis is the opposite of the null hypothesis, and will state that there is a significant difference between the mean test score of the two groups, and the one teaching method is more effective than the other. Or you can also compare the academic performance of students. And in our case, we can use standardized scores like KCSE scores, but some countries use the GPA, grade point averages, between two schools. And here, I have given my null hypothesis as there is no significant difference between the mean GPA of students from the two different schools. And the alternative hypothesis will be there is a significant difference between the mean GPA of the two schools. And of course, you can state the directional hypothesis. I want to move on because we have stated the hypothesis now, but I want us to move on and get now to get into this directional hypothesis and the directional hypothesis. This comparing the reading comprehension is another example, but I don't want to develop in that because you can get what. So I've talked about directional hypothesis, and I said it's a type of hypothesis in which a researcher makes a specific prediction. So when you are making a prediction in your hypothesis, you are giving the direction of the relationship or the difference between the two variables. Then that one becomes a directional hypothesis. In other words, a directional hypothesis is able to predict that one variable will have an effect on another variable in a particular direction. For example, a direction hypothesis in an education study might predict that the student who receive a new teaching method will perform better on a math test than the students who received the traditional method. The hypothesis predicts the direction of the effect, stating that the new teaching method will result into higher math score. Directional hypotheses are often used when there is an existing theoretical or empirical evidence to suggest a specific direction of the relationship of or difference between variables. They can be tested using statistical tests such as one-tailed t-tests, which are designed to test for significance in a specific direction. And it is important to note that direction hypotheses carry a higher risk of producing a false positive result. And we will look at this word false positive. It is a loaded word, false positive. What is it and how does it affect research results? So whenever somebody is having a directional hypothesis, he might or she might be able to produce a false positive result if the direction of the relationship or difference is not correctly predicted. Therefore, we should be able to take this directional hypothesis with caution, and it must be supported by strong theoretical or empirical evidence before we use it. What is a false positive? What is a false positive? A false positive result is a type of an error. So this is an error in statistical hypothesis testing that occurs when a null hypothesis is rejected, even if though it is actually true. In other words, a false positive occurs when statistical tests incorrectly indicates that there is a significant difference in a relationship between two variables when there is no such a difference of relationship in reality. False positives can occur for a variety of reasons. And one of the reasons include sampling error, measurement error, and the violations of the assumption of the statistical test, which we already saw at the beginning of the lesson. So when you have a problem in sampling and you have a sampling error in your data, also you are using your measurement tools, and these measurement tools are not properly coded. So whatever they are measuring is not correctly. And we have violated the assumption of the statistical data, and I said there are three for these tests, for this independent sample t-test, this normality, independence, and homogeneity or variance. If you have to violate this, then you're likely to get a false positive in your results. For example, suppose a researcher is conducting a study to evaluate the effectiveness of a new teaching method designed to improve student performance in mathematics. The null hypothesis will be the new teaching method has no effect on student performance. And the alternative hypothesis will be the new teaching method does not improve student performance. To test this hypothesis, the researcher randomly divides a group of students into two groups. One group receives the new teaching method, while the other group receives the traditional teaching method. The researcher then administers a math test to both groups of the students and compares their scores. If the results of the statistical tests indicate a significant difference between the mean scores of the two groups in favor of the new method, the researcher may conclude that the new method is effective and should be adapted in schools. However, if the statistical test produce a false positive result, the researcher may mistakenly conclude that the new teaching method is effective when it's actually not. And suppose that the statistical test falsely indicate that there is a significant difference in the mean scores of the two groups, even though the difference is due to a chance or other factors. These false positive results may lead the researcher to recommend the new teaching method to schools, even though it is not actually effective. And this could result in wasted resources, and students may be taught with an ineffective method, leading to poorer performance and educational outcomes. So these are some of the effects of false positive results. Therefore, it is important for researchers to be aware of the possibility of the false positive and to take steps to reduce this type of error. And how can we reduce this one? How can you reduce the errors of the false positive one? By controlling, by using appropriate statistical tests. Second, in ensuring that you have adequate sample sizes. And 3, make sure that you replicate the findings. And also, you should be able to control the potential confounding variables. When we were beginning the other course, I talked about the confounding variables in the study. And at the moment now, we know what the confounding variables are. So you should be able to control for the confounding variables in the study. And researchers can also use techniques such as cross-validation and replication to ensure that findings are robust and not driven by chance. What are the advantages of using directional hypothesis? I did say that directional hypothesis may lead to production or producing of a false positive results. And I was discussing about the false positive and how we can avoid them. Now I come back to the directional hypothesis. And now I'm going to discuss the advantages of using directional hypothesis. And one of the advantages is when you're using directional hypothesis, you increase the statistical power. You increase the statistical power. Directional hypothesis can increase the statistical power of a study, which is the ability to detect a true effect. By specifying the direction of the effect, researchers can focus their analysis on a specific outcome, which increases the probability of detecting an effect if it exists. And this is particularly useful in studies with limited sample size or low effect sizes. Number 2, the advantages of using directional hypothesis. Number 2 is greater theoretical precision. Directional hypothesis can provide greater theoretical precision as they allow researchers to make specific prediction about the direction of the effect. And this can help to clarify and refine theories, and it can provide a more focused and hypothesis-driven approach to research. Number 3, improved research design. Directional hypothesis can improve the design of the study by guiding the selection of the appropriate statistical tests, sample sizes, and other design elements. For example, if a researcher has a directional hypothesis that a new treatment will be more effective than a standard treatment, they can design the study to compare the two treatments in a way that maximizes the ability to detect a significant difference. And finally, number 4, it will facilitate the replication. Directional hypothesis can facilitate the replication of research findings as they provide clear and specific prediction that can be tested in subsequent studies. This can help to build a stronger foundation of evidence and increase the confidence in research findings. Although it has these advantages, the directional hypothesis has also limitations. And there are about 3 limitations which I'm going to look at. 1, directional hypothesis carry higher risk of producing a false positive results, and if the direction of the effect is not correctly predicted. This can occur if there are unanticipated factors that influence the relationship, or if the sample used in the study is not representative of the population. Number 2, directional hypothesis may be less appropriate in exploratory exploratory research, the research that explores, where the goal is to explore and generate hypotheses rather than to test a specific hypothesis. Finally, directional hypothesis may be less appropriate in fields where the underlying relationship between variables are complex or poorly understood. So these are the limitations, the three limitations which are there and can limit one when wants to use directional hypothesis. In conclusion, the use of directional hypothesis can be advantageous in certain contexts, but it's also important to consider the limitation and the potential risks with their uses. Researchers should therefore carefully consider the theoretical and empirical support for their hypothesis and should use appropriate statistical tests to test their prediction.